Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 Time Zone 0 in November. Question number 32 relates to the topic of organic chemistry, topic 10, important and long topic. Let's see. Which compounds causes the color of acidified potassium manganate 7 solution? So that is a really famous oxidizing agent, right? And the key feature, the key ion within this compound will be the MnO4 minus, acidified, so stroke negative, stroke H plus, right? To change from purple to colorless. Purple to colorless, which is a really important color change when the permanganate ions is really reacting. So you will see the purple permanganate will switch to the colorless ion of manganese 2. So after the reaction, the permanganate ion will then be reduced to the manganese 2. So this is going to be purple to colorless. Make sense? So that means now you're asking for which of the following are able to be subjected to the oxidation with or by the potassium manganate 7, right? So in this case, asking for really classic oxidation reaction of organic compounds, right? Obviously goes to the major functional group in this question, the alcohol. So remember, we should be reminding you that primary alcohol and secondary alcohol are both able to subject to oxidation, but not tertiary alcohol. Tertiary alcohol cannot follow oxidation. Secondary alcohol will be able to follow the oxidation and get to the compound called ketone, the next functional group. For primary, it's easy for the same logic. It can undergo 2 rounds. The first round go into aldehyde, right? And the final rounds goes to a carboxylic acid. So which means it can go 2 rounds. First to aldehyde and carboxylic acid. So which means both primary and secondary alcohols are able to undergo oxidation. So which means now we should find out which of the following alcohols are primary or secondary, but not tertiary. Let's see. For the first one, as you can see, right, the hydroxyl group should be attaching to this carbon, the one that I'm pointing, that within this carbon, if you look at it so carefully, it has bonded to 2 hydrogens, but 1 adjacent carbon. So which means if I don't draw this out, students should have realized that this is going to be a primary alcohol. And so primary alcohol is okay, right? So 1 is okay. Let's see. For 2, pretty sure that you look at so carefully, because don't think that here having 3 CH3s, 3 CH3s means this is going to be tertiary. Be careful. We must be looking for the carbon that has bonded directly to the hydroxyl group. So in this case, the carbon bonds to the hydroxyl group should be this one that I'm now pointing. Or now I just squared, right? And these carbon, you see, adjacent bonds to still 2 hydrogens and 1 carbon adjacent. So that's why still be a primary alcohol, right? Be careful. So that's why this is also okay to be able to undergo oxidation, right? So finally for 3, this time you can see the hydroxyl group is being bracketed in the middle of the carbon chain. So which means this is going to be a branch in attaching to this carbon, right? That has also linked to 1 hydrogen, but 2 adjacent carbons. So which means the carbon linked to the hydroxyl group bonds to 1 hydrogen, 2 carbons, which is going to be a secondary alcohol. Still, secondary alcohols are able to undergo oxidation to become a ketone. So that's why it is also okay for 3 to be undergoes oxidation with the permanganate ions under acidified condition. So that's why answer easy will be D.